All right, hello and welcome. I'm going to do a review video for our first semester study guide. I'm just going to kind of jump around and try to tackle some of the harder problems here. Definitely use some of the older videos to help you study, look over the old reviews, other homework help videos. I'm just going to try and go after a few of the harder problems. Do this a little bit quicker as maybe just a way to get your studying process started. Not necessarily to really cover the entire semester in one video. I don't think that would be a great idea or really doable considering how much content we've covered. But okay, I think maybe somewhat difficult type of problem would be these absolute value inequalities at the bottom here of the first page. We need to solve these and graph their solutions. A lot of things going on here. First thing is I want to make sure my absolute value bracket is isolated. So let's deal with problem number 10. Absolute value of x plus 2 is less than 6. So if there's any operations outside of the absolute value bracket, I want to move them to the other side before doing this next step. But there's no operations out here, so I'm just going to go into the next step. If we look up at like problem number 8, I would want to probably move that minus 2 before I did this next step. So what I'm going to do is I'm going to split this absolute value into what I call the positive and the negative case. In the positive case, the value inside is positive and the brackets don't have a job to do. So we can just drop them. I'll get x plus 2 is less than 6. In the negative case, they do have a job. They have to take that value, which is negative, and make it positive. And they do that by multiplying it by a negative 1. So negative parentheses, x plus 2 is less than 6. Before I did this, I should have double checked that we weren't less than a negative number, because then it would be no solution. But that's not the case here, so we can keep going. Over here, I'm going to subtract 2 from both sides, and I get the inequality x is less than 4. Put a circle around that. And over here, I'm going to distribute that negative. Get negative x minus 2 is less than 6. Add 2 to both sides. Negative x is less than 8. Divide both sides by negative 1 to get rid of that negative there. And in this step, I just divided by a negative, so I need to remember to flip the direction of my inequality symbol. And with absolute value inequalities, one of the two will always have your inequality flipping direction, because they won't ever be pointing in the same direction. They'll always either be intersecting or diverging when we graph these. All right, in order to graph x is less than 4, I go to 4 on my number line. I put an open circle because this does not include the endpoint of 4. It doesn't have that or equal to. And then the arrow points in the same direction that this is pointing. If I turn this into an arrow, you'd see it's pointing to the left. That trick only works when your variable is on the left-hand side, which it is here. So that arrow is going this way. I won't add the end of that arrow yet. I'll come over and graph this one. Open circle at negative 8, arrow going to the right. These connect up to make a line segment. So the solution was x is less than 4 and x is greater than negative 8. And because these two arrows overlap, and we only want to keep the overlap. If they diverged and didn't make a line segment, we would write the word or. All right, moving on. Graphing, maybe this one here. Just do real quick. In order to graph this, I need to get it into slope-intercept form. In order to do that, I focus on trying to isolate y. So I need to move all the terms away from y, so maybe add 3x to both sides. Negative 4 plus 2y equals 3x. Add 4 to both sides. 2y equals 3x plus 4. And then get rid of the coefficient by dividing every term by 2. Y equals 3/2 x plus 2. Now in order to graph this, I'm going to go to my y-intercept of 2, place a point, and then attach this slope of 3 over 2. So we go up 3 over 2. I can't go any further forward, so I could multiply this by a negative 1 over negative 1, which would be a form of 1, and go down 3, backwards 2. So up 3, forwards 2 is the same as down 3, backwards 2 when you're dealing with lines, and I can keep doing that until I'm off the graph. And then maybe connect these up with a solid line. Kind of like that. All right. Let's do 15. 15 seems like a good one. First thing is perp. What does that stand for? Perpendicular. And so we know that the line is going to be perpendicular to this. What do we know about perpendicular lines? Well, that they have opposite reciprocal slopes. So I'm going to take that 1/2. I'm going to flip it upside down to make it its reciprocal, 2/1, which is equal to 2. And then I'm going to make that -2 so that it's the opposite reciprocal. So I know that my slope has got to be -2 because I flipped this upside down and made it negative. I also know that it's going to go through the point 1, 1, so that gives me an x and a y value that I can borrow. So let's write out y equals mx plus b, and then let's fill in what we know. We know that it goes when y is equal to 1, x is equal to 1, and that the slope is -2. What we don't know is the y-intercept, so we just leave that as b, but we're going to solve for it real quick. Add 2 to both sides. We get 3 equals b. So I've got an m and a b value. I borrowed the x and the y, so I give them back. And I write my final equation. Y equals -2x plus 3. All right. Graphing absolute value. Linear inequalities. Yeah, maybe I'll do 19 just real quick. Let me get this into slope-intercept form. We're going to move the 2 to the other side, make it a -2x. Divide everything by -3. Remember, when we divide by that negative, our inequality flips directions. And we get 2/3x plus 3. Point at 3, up 2/3. Down 2, backwards 3, down 2, backwards 3. So once you've dotted in your line, then refer back to this symbol for whether you want to use a solid line to connect the dots or a dashed line. Here we definitely want to use solid. We want to include the line itself in our solution set because it's got this or equal to. Now we've got a shade on one side. With it set up this way with y on the left-hand side, then a less than means lower. We want to shade below this line. So in this region down here is all of the ordered pairs that would make this inequality true if I plugged those ordered pairs into the inequality above. So, all right. Solve by graphing, substitution, elimination. I think we're pretty solid with that. System of inequalities, you just graph them twice and keep the overlap. Let's deal with this word problem. All right, so they're selling tickets. On the first day, they sold tickets to 9 adults and 1 child, and they made $130. Second day, made $74 by selling 3 adult and 8 child tickets, price of 1 adult and 1 child ticket. So we'll say A equals the cost of an adult, and we'll say C equals the cost of a child. And if I take the cost of an adult, multiply it by the number of adults, 9, add it to the cost of a child, which we don't know, so we'll say C times the number of children, 1, we'll make $130. Same logic for our next equation. 3 adults plus 8 children equals 74. I think this would be a good opportunity to practice doing solving a system with matrices. This is a 2-equation, 2-variable system, so I'm going to go second matrix over to edit and create a 2 by 3 matrix. This way I've got a row for my x values, a row for my y values, and then also a row for the solutions at the end. Just resize this a little bit. All right, let's plug in what we have. 9, 1, 130. 9x, 1y equals 130, or I guess it's A and C. 3, 8, 74, 3, 8, 74. Get out of the matrix, go back into the matrix, come over to math and choose reduced row echelon form, which is alpha B. Go back to the matrix a third time and select the matrix we just created. Now we are going to do the function reduced row echelon form on matrix A. And we'll get our answers of 14 for an adult, 4 for a child. So $14 per adult, $4 per child. Three variable systems work the same way. Just use a 3x4 matrix. Sketching from vertex form. I guess we'll just practice. 27 real quick. Put a point at the vertex of 1, 3. I get that from my h and my k value. Remember to always flip h. And then I use this pattern 1, 4, 9. I manipulate it by my a value. A here is equal to -1. So this becomes -1, -4, -9. So if I go over 1 unit, I come down 1 unit. Make it symmetrical. And if I go over 2 units, I come down 4 units. And I'm off the graph, but there is my parabola. Looking like that. All right. Moving on. Identify the vertex and axis of symmetry, then sketch the graph. So what I'm going to do with this one, I think this would be a good one to do. I need to get it into vertex form, so I'm going to divide everything by 3, including dividing this by 3. I get y over 3 equals x squared plus 12x plus, let's see, it's going to go in 31 times. No, 1 second. 3 goes into 103. Not even amounts. I'm just going to leave it as 103 over 3. That's all right. My fraction should go away when I send the 3 back. All right, now I'm going to rewrite this middle part as an x plus something squared. That something is always half of my b value as I see it there. But that means I've got an extra 36 that I've got to subtract away. So I've got the 103 over 3 minus 36. The side is still y over 3. That 36 is the same as, what is 36 times 3? 18 plus 90, 108. So 33 is the same as 108 over 3. So 103 over 3 minus 108 over 3 is a -5 over 3. So let me write that. Minus 5 over 3. Time to send the 3 back, so I multiply everything by 3. And I'll get y equals 3 times x plus 6 squared minus 5. 5 over 3 times 3 is just a -5. So where's the vertex? -6 comma -5. -6 comma -5. Where's the axis of symmetry? Well, that's a vertical line that goes through the vertex, so it's just x equals -6. Can add that in. Dotted line. There's my axis of symmetry, x equals -6. And now, instead of going up 1, 4, 9, I'm going to go up 3, 12, and I should be off the graph by that point, but 27, because I'm multiplying everything by 3. So over 1, up 3, 1, 2, 3, make it symmetrical. Over 2, up 12, 3, 4, 5, 7, 9, 11, 12. make it symmetrical. All right, there's that one. Solve by completing the square. Oh, that's very similar to how we convert to vertex form. Let's just practice that real quick. I'm going to rewrite these terms here, as n minus 2 squared, but that's going to give me an extra 4 that I've got to get rid of on that same side. Now I'm going to I guess combine like terms and then move this 39 over to get that n minus 2 squared equals 46. Square root, n minus 2 equals plus or minus the square root of 46. Add 2, n equals 2 plus or minus the square root of 46. Let me just double check that. Let's see, that was 31. Yep, got it. Now, first unit of next semester, we're going to be learning how to simplify radicals. This was one that couldn't be simplified. But don't worry about simplifying radicals yet. In case you see that anywhere in the answer key, your answer's probably fine. Solve by factoring. Let's just do 32 real quick. I can factor in an m, leaving behind an m minus 7 equals 0. This gives me the answers of m equals 0 and m equals 7 after I apply the zero product property. Quadratic formula, sketch a graph. This is a quintic trinomial. Cool name. End behavior, this one looks like it's up because they should match because this is even, and it should finish up because this is positive. All right, we got some polynomial ones here. So I guess we'll do, should have done a harder one for 39. Should have at least put one imaginary root in there. But okay, 39 is not that difficult. We just use factor theorem to relate these roots back to their corresponding factors. I didn't even put a fraction in. Man, I made this one way too easy. And then you just FOIL this. So I'll get an x squared plus 5x plus 2x plus 10. And then just keep distributing. And we'll get x cubed plus 7x squared plus 10x. Simplify number 40. I need to multiply by the complex conjugate, which would be 7 plus 3i. 7 plus 3i to the top and the bottom. Just flip that middle operator. And then FOIL the top and the bottom. And let's see what that looks like. Negative 70 minus 30i minus 42i minus 18i squared, which then becomes a positive 18. And then on the bottom, I'll get a 49 plus 21i minus 21i minus 9i squared, which will become a positive 9, because I squared is equal to negative 1. Combine like terms, and we're going to see we've got negative 52 minus 72i, all divided by 57. And I don't think there's any common factors there. If there are, we might be able to take them out. Let's take a look at 40, what's it supposed to look like. 40. Oh, they divided everything by 2. Was everything divisible by 2? Yeah, 49. That should be a 58. So yes, everything's divisible by 2. Negative 26 minus 36i over 29. All right. Long division. This one, because we're dividing by a very simple binomial, we could just divide by its related root, which is a -8, and use synthetic division. So for 41, we could set this up as 8, 69, 33, -56, divided by the root, which is -8, so 8, -64, 5, -40, -7, +56, 0, and then you just use this row here to get your final answer. 8x squared plus 5x minus 7. All right, state the possible rational zeros for the function. So factors, there are things that divide into 4 evenly, 1, 2, and 4. Things divide into 3 evenly, 1 and 3. All the fractions possible with these numbers from the last divided by the numbers from the first. That's going to be 1 over 1, 2 over 1, 4 over 1, 1 over 3, 2 over 3, 4 over 3. Find all roots, just use the zero product property, set these equal to 0. 44 is our super long problem. Find all roots, 1 has been given. I guess we'll do this one. I'll just do it quickly. So if x 1 plus I is a root, then 1 minus I is also a root, and x minus 1 minus I and x minus 1 plus I are also factors. Notice I had to do a little bit of distribution to get this. I just did it in my head. Let's distribute these. Get an x squared minus x plus ix minus x plus 1 minus I minus ix plus I minus I squared, which that's going to be, so I squared is -1, so negative I squared becomes a +1. Anything with an I basically cancels out, and I'm left with x squared minus 2x plus 1 plus another 1 plus 2. So here's the quadratic factor that should fit into this quartic evenly. Let's go ahead and do that math now. X squared minus 2x plus 2 fitting into x to the 4th minus 5x cubed plus 4x squared plus 2x minus 8. X squared fits into x to the 4th, x squared times, giving us an x to the 4th minus 2x cubed plus 2x squared. Subtract, and we'll get negative 3x cubed plus 2x squared. Drop down the next term, plus 2x. Next one is going to be a negative 3x. Giving us a negative 3x cubed. Positive 6x squared. And a negative 6x. Subtract negative 4x squared. Plus 8x minus 8. Multiply by a minus 4, and let's just see, that gives us a negative 4x, positive 8, negative 8, good, remainder 0. So here's what remains, x squared minus 3x minus 4. Is that factorable? Negative 4 and 1, yep. X minus 4, x plus 1, which gives us the additional answers of x equals 4 and x equals negative 1. All right, first term of the expansion of this, well, its coefficient is super easy. All of the first terms always have a coefficient of 1. And then it's going to be a to the fourth b to the 0th. That will go away. The 1 won't matter, so all we have to do is take the 2v and raise it to the 4th. Don't forget to distribute that 4. 2 to the 4th is 16. V to the 4th. Man, I made that one easy. All right. Now that you finished this review, the next documents you should go over are old homework. Start with the reviews for each test. I think I threw you some softballs in this review. Potential that I might do something a little bit more challenging. Like this binomial expansion one was a little bit too easy. Maybe go and try to expand that one all the way. 44, that was more on par with what you'll see on the test. Where's another one that I made too easy? This long division, because you could do it with synthetic division. I made that too easy. But the test is not going to be the most hard versions of every problem that we've seen so far. So in all honesty, this is actually more similar to what the test will be like. Kind of wish I'd made a few of these a little bit harder. There was one more that I thought was just like way too easy. Which one was it? No, I mean, this is pretty similar to what the test is going to be like. So it's a good review. Yeah, and then I want to highlight again, go and review linear programming, piecewise functions, and regression on the calculator. Those are 3 things that aren't in this review, just because adding them to the review would have been too difficult, and I figured I could just tell you to go review those 3 things and that'd be okay. All right, so that's that for this review. Have a great rest of your day.